Hope everyone's had a great break. Looking forward to resuming shortly. Hi, everyone. Welcome back. Hi, Eli. I'm so happy to have you here.
Good to be here.
This is my favorite part of today. So excited to hear today from Eli. I've known Eli for a while now, and I'm really honored to have him today for our closing keynote. Eli, I'll introduce you very briefly, and you'll probably have, I'm not going to be able to do justice in the short time that I have, so we're going to have to hear the full story from you. But for folks who don't know, Eli is VP Product at Google DeepMind. Google DeepMind is and has been at the forefront of AI research and product development with projects such as Bard, many others that you've heard about, text-to-image diffusion models like Imagen, and over the past 10 or more years have actually sort of set the standard, I would say, for what ethical and responsible AI development means. I have lots of questions about that. Before joining Google, I think I met you at the time when you were actually an EIR at Excel. Prior to that, you were chief technologist at Cloudera, and prior to that, joined VMware very, very early on. So you've seen sort of numerous transitions in the industry. Have been here pre-cloud, post-cloud, pre-Gen AI, post-Gen AI, if we can even sort of draw the lines in that way. But I'm really, really excited to sort of hear from you. So maybe, I'll just start by asking, for folks who actually want to follow in your footsteps or kind of understand sort of, what does it look like to sort of have a career like yourself, Eli? Like, how did you find yourself at sort of these sort of different points and intersections in history?
Yeah, well, first of all, thanks for having me. It's great to be here. It's kind of fun to see. I remember when Monte Carlo was an idea, so really excited to see it become so much more than that. And so, like my career, I feel like only makes sense in hindsight. I, did some startups in the early .com era that were like good ideas in 1999, but like way, way over invested, kind of got over their skis. And so went to grad school, came out to VMware for an internship, and dropped out. But basically ended up spending the last kind of 15, 16 years of my career commercializing research and working at companies where it was like a research paper turned into a company. So like VMware started with a research paper, Google started with a research paper, Cloudera was built on a lot of research from Google, Yahoo, Facebook, others. And so I didn't intend to do that. Like I just was being kind of a PhD dropout and kind of interested in how wanting to go faster than you could go in a research environment in terms of building things. Just kind of lucked into those options. Like it's, I think there is a component of it of just where the tech has gone in my career. Like I remember reading books growing up and feeling like I missed out on the PC era. Like I grew up with an Apple II and then a Mac, and I was like, I wish I grew up at the like era of the PC, and I did grow up with the internet. So it's one of those things where I feel like every, technology has these eras, and then like, when we work has so much to do with like what we end up doing. So just like to your point, like cloud, AI, those are just like the revolutions that have happened in our industry while for the last 20 years. So ended up kind of getting pulled into them.
Nice. Awesome. Sounds like it's been a fun ride regardless
Yeah.
of how it happened. So maybe jumping to sort of the topic of the day, it feels like generative AI is everywhere and everything. But one thing that you and I have spoken about is that actually maybe it's not that new. And in fact, y'all have been working on this for quite a while. And maybe, just give us sort of like the 30,000-foot view of, your opinion of like how we got here, what's important, what's interesting or new now.
Yeah, it's funny. We've been at Google talking about ourselves as an AI first company since 2015, doing a lot of AI work, but it does feel like there's something different in the last year or two. And I think a lot of it is just the with exponentials, you can work on something for a while and then only until it kind of becomes good enough that people notice. And so I think, like, I remember when I was in a lab as an undergrad trying to get into grad school, working in an office where these people were doing something called neural machine translation, which is doing translation with deep neural nets. And this was in like 2001, and it like wasn't working, and they were kind of stressed out, and they had these like big beefy PC. At the time, it's like less than your phone now, but like at the time, like these big workstations, and it wasn't working. And then, but like by 2005, Google had developed deep models for translation and launched Google Translate, which is now like a multi-billion user product standalone, billion plus user product standalone, but also used in Chrome and ads and YouTube and search and all over the place. And so, but was really a generative translation is a generative AI model. Like that's what, sometimes the translations are wrong and we have to fix them, and it's wrong because the model is literally, it's the same kind of issues you can see with any generative AI. So we've been on this journey before, and it's, things like translation and summarization have kind of worked. But I think what's really new is just these multitask models where it's not just translation, summarization, sentiment analysis, it's arbitrary. Like models have become more like, it's a new type of developer building block rather than like a function to implement something like translation or summarization. And then just the quality gains, over the last couple of years, just because of where we are on those exponentials have just started to get amazing just in the last kind of 2 to 3 years. And so I think those two things, just like multitask, multimodal models kind of being just a different building block than what we had before, and then just the sheer performance. But both of those two things are kind of new to in the last, say, 3-4 years.
Yeah. And I mean, maybe along those lines, like how do you view kind of like the day-to-day life of an engineer or, data person changing fundamentally as a result of these new building blocks?
Yeah, it's hard to say. Like I still think we're in the early, it still feels early. Like we've been putting AI in our internal developer tooling for a long time. So for example, like, automatically fixing builds or code completion in the IDEs, or suggesting to developers like, hey, if you want to make this release, like predicting which release, what branch and what release a code change should get checked into. And so we had been kind of putting, we've been in this mode of just figuring out how AI could be used to improve developer workflow. And there are lots of examples of that are just kind of incremental improvements of the existing workflow. I think the bigger changes are going to happen when the whole workflow changes. That's versus optimize. I think there's like a lot of, and still a huge amount of runway in terms of humans and computers working together and kind of co-developing things. Like that's clearly like, working. If the workflow totally changes, then you could start to see kind of bigger changes. But for right now, it seems, I haven't seen anyone's job totally change internally because of the tech. It's just been a way to kind of do things we do better. So for example, like, tuning complex systems is really hard. I feel like anyone who's run a large database has dealt with that, but pretty much any kind of distributed system. We have a service that will optimize configuration parameters, so you don't have to figure them out and tweak them by hand. It'll use machine learning to like optimize them for you, which when you operate a cloud service, you can kind of do end-to-end infrastructure like that and make it work, and the kind of at a large enough scale, it's worthwhile. And so I think a lot of that stuff is just going to be commonplace. Like the idea of tuning a database by hand, is going to eventually become antiquated. And but partly for that to happen, people also have to shift to the cloud, because it's hard to do that. Like some of these things are just hard to do if you're not running your own cloud infrastructure on someone else's cloud infrastructure. And I think that like the shift to cloud is really important. I mean, obviously it's a big thing in of its own sake, but part of it is it's going to enable all of these ways that you can just kind of seamlessly start using AI and in ways that just make things better and easier and faster by default.
One day we'll be able to do that on our phones, is what
Yeah.
I hear.
I mean, I have seen, if you told me people were going to code on phones, I would have, I would have said like, no, like as a former programmer who's like checked in code into like, Linux and getting in minor way, working a lot, mostly at Apache, like I would have thought coding in a phone was just never going to be that interesting. But like people do that. I mean, Replit has an interesting mobile coding app, and I would have said the same thing about doing homework. But like my sister's a public school teacher, and like so many of her kids do their homework on Google Apps and Google Classroom, like on their phone. They don't even use their Chromebook. And I'm like, for me, that would be like the idea of writing a document on my phone doesn't make sense. But I grew up, with the PC era, and they're growing up in the mobile era, and so I think there's also just some of this stuff is, comes back to the platform shifts. And so, yeah, I mean, I can imagine people coding by voice and mobile and all sorts of things.
Yeah, super exciting. So let's talk a little bit about use cases. I think you were recently on 60 Minutes to talk about Google's latest advances in AI. And I won't spill too much. Folks should go see it. If you want to see pink taxi cabs, that's my hint. But you talked a lot about sort of text to images applications in particular. Can you speak about that and maybe like what are the use cases? I was playing around with a French beret dog on a mountain, and sort of like various applications, obviously that are easy sort of to do on the website. But how do you actually see this in practice, or what are some of the use cases that you're most excited when it comes to text to image?
Yeah, and this is another area where like we've been doing, putting kind of generative models on Pixel. So for example, Magic Eraser, there's like someone in the background, you point them, they like disappear. That's generative AI, just like in a kind of narrow, easy use, limited sense. And so it's an area where, we had a lot of expertise. We've subsequently launched generative imagery in a bunch of products, like even since the 60 Minutes demonstrations. So like slides now, like you can imagine, generating, so there's like stock imagery in Google Slides, but like you can imagine generating your own, like you're planning, a birthday party or something or a wedding, and you want to like just prompt ideas and poof, you can get generative imagery to kind of like generate creative assets. We use generative AI in ads, so we can generate copy, images, et cetera. So there's a lot of ad optimization where generative AI kind of plugs in, where it's kind of automating the creative development. And then I think there are a lot of areas where people are just if we recently put our latest generative model in what's called SGE, or Search Generative Experience. It's kind of the search labs. It's kind of interface to search, and we put it in a couple places. One was in image search. So for example, if you're doing an image search and then you don't like any of the images in the search, you can actually generate an image that might be similar to the prompt you're searching for. And so you can almost think of like generative imagery as the opposite of image search, in the sense that sometimes search is about finding an image, but sometimes it might be about generating the image if you can't find it. And so for some of the use cases where people are using search for kind of creative inspiration or brainstorming or planning, they're not necessarily looking for like sometimes they're using image search to find an image, but they're not actually trying to find an image. They're actually just trying to do actually something more creative. And sometimes generating an image is actually a better use case. So I think there's ways that it'll just get, put in areas where we can kind of up level the user experience to see like, hey, for slides, do you really have to be limited to stock? Like why should a slides program like only generate the same set, like have a stock set of imagery? Like why shouldn't it be able to generate any image based on the slides you want to create? So I think there's a lot of things like that where it will just help us remove kind of product constraints.
Yeah, I'm personally really excited about generative AI and sort of arts, creative side like music and art and such. So excited to follow that. And I know when you mentioned this, sort of we're still in the early days, but one of the things that a lot of sort of folks in our audience are thinking about, how do I get started, and what does the sort of modern LLM and modern AI stack look like? For folks in enterprise who are starting to build that out, what do you think that is going to look like, or looks like today?
Yeah, I mean, I think part of why it's such a hard space to follow sometimes is there's activity happening like up and down. It's a new stack, and then there's the stack is growing, and then there's activity happening up and down the stack. So like at the most high level, the way I just organize my brain is like you have the kind of prompt first development where I mean, you kind of see this on with tools like Midjourney, where it's like people are just becoming like they've never experienced something. They're loading an app, they're starting to prompt Midjourney, and they're using it in their work. Like they're just kind of it's almost like creatives who are learning prompt engineering, and it's like prompt first development. And you see that with language models like Palm and MakerSuite at Google and so on. And so that I think there's this kind of people prompting is a form. It's almost like Excel. It's like the number one. There's probably more Excel programmers than any other type of programmer. It's the same with I think prompting is creating that kind of new class of development, and that's at the highest level of abstraction. It's the easiest to get started. Like you can go to Bard and start coding with prompts today, even if you don't you're not an expert. So we see a lot of people go to Bard to learn how to like create Excel macros and whatnot, and they just have this kind of prompt first, very seamless way to get started. The next level down, I would say, is like the API developer. So it's people who a bit deeper than kind of prompt first. Like they're gonna issue JSON calls. They're gonna think about integrating something in an application. Like it is still fundamentally, it's more closer to like traditional software development than kind of prompt development. But it's still very high level. Like the APIs are probably taking care of a lot of the infrastructure that you might not want to build in-house. That's just getting solved for behind the scenes, like safety. Like for example, if you think of taking a raw LLM versus what you want out of an LLM API, like there's a huge stack of technology around the difference between the output from the model and what you want to output in the API. Like that, there's all sorts of things that you might want to do. Like you might want to ground on a database. You might want to run trust and safety classifiers. You might want logging, et cetera, et cetera. So there's like all sorts of kind of niceties. So you're still doing software development, but you're like building on a whole stack of technology. Then the next level down, you have people who can take a model checkpoint, and it could be like an open source model, but like they fundamentally want to consume a checkpoint of the model, and then they're going to integrate it in their own infrastructure. So obviously, like a next level down, they may be taking a model checkpoint plus internal systems, tying them together, and integrating them as part of like building some kind of larger complex system. And then really the LLM checkpoint is like the building block. And then finally, the lowest level of development is people building their own models. So there are people, we've got people who are using massive models and fine tuning them, or building their own models from scratch. Maybe using BERT, like I think BERT's like 4 million downloads last month on Hugging Face, T5X, one of our other open models, 500,000 downloads last month on Hugging Face. So people, there are lots of people who are taking existing open source models, building their own models from them, and running a whole kind of model development pipeline from scratch. And so that's obviously the most difficult and sophisticated. But I think I think there's a lot of interesting project and work going on at every level of abstraction. Like I think both all of them have kind of interesting things going on.
Yeah, for sure. As you mentioned, and everything is changing all together at once. And so I think, one of sort of the big advantage is that anyone can do this today, right? Anyone can build their own model. But then I don't know if it's a disadvantage, but one thing to consider is what is sort of a responsible way to build in that kind of world. And so how do you all sort of define, what responsible AI looks like? Does it even matter? What should, sort of the citizen LLM builder should even think about in this space?
Yeah. It's obviously like, deep technical topic that's also like front page news, and like very top of mind for like the industry and government. So it's at DeepMind we've written a great deal about kind of the social and ethical risks of LLMs. We can share links on that. And there are all kinds of hazards and risk areas, right? Like, so you've got malicious uses of the technology. You have kind of downstream things from that, like misinformation. There's a whole range of things you have to look at, but you have to look at them through their point of origin. So for example, if you think of like, we do a lot of work, for example, on our pre-training and making sure we're, keeping the wrong data out, making sure we have the right data in, data prep, cleansing, et cetera. Like there's a lot of work that if you want to build a model that's compliant and can be launched in products across the world, a lot of rigor goes into preparing the data sets for those models. Like you have to make sure you don't have any PII, et cetera. So it's really like you really have to look at it kind of at the point of origin. When you deploy the models, like we talked about like trust and safety and kind of the classifiers and filters. You don't want to just deploy the model output and have it directly read. If you're building an application for end users, having exposing people directly to the model probably not a good idea. You have to think through all of the use cases of the product you're building and like what are the intermediate layers that have to be developed. And obviously, then there's also all sorts of work that we do with like governments and policymakers on trying to craft rules that make sense, where you can kind of prevent the harms, but also enable like all the innovation in this space. And like, how do you find that middle ground? Because both are important, right? Like, you don't want to go too far in either direction. So it's a big, complex space. There's not like one single solution, but it is something you really have to think about holistically.
And when you think, that's great, I agree with you. There's like both of those sides, like the technical problem and how do you handle this in the media? I guess for sort of an average company who wants to like get up and running, or an average enterprise who wants to start with LLMs, like what are the biggest challenges today, considering all of this?
Yeah, I mean, I think it to some extent depends on where in the stack you are. So like building your own model is not for the faint of heart, right? That's a new there's a lot of great open source tooling to build a model. Like we've published a bunch of it, whether it's open source frameworks like TensorFlow and JAX or like T5X, the model development. Like you can do it, but it's there's just tons of amount of expertise, and then you have to, like, for example, in the discussion about harms, like you have to understand all the issues at the whole stack. So kind of complexity. Prompt first, just to go on the opposite end of the spectrum, you don't really have a lot of control. Like you are pretty it's the model is kind of a black box, and you're experimenting with it. But as we've discovered with prompts, like it's not they're not APIs, like they're not backwards compatible. Like it's a more, if you think about I use the comparison to like an Excel macro. Excel macros are deterministic. The models aren't. So so I think that's like the ecosystem is working on that. So because obviously that makes it challenging to build applications, but on even for a prompt first development where so many of the backend issues have been solved for, I still think we're really early. Like if you think of I spend a lot of time in the data world and the database world, and if you think of like all the standardization that SQL like went through and UDFs and getting us up to SQL. I remember when SQL 92 came out, and just like all the complexity that like product like BI tools and whatnot had to do to support the new dialects, and then across all the vendor implementations. And like SQL is a pretty constrained language. Like it's really broad and powerful, but it's a subset of like what an LLM can do. And so if you think about a new if you think about just from a complexity of someone who's kind of thinking of dealing with these almost like it's a prompting as like a programming language, it's a lot more black box. It's a lot more open-ended. Like it's not like writing SQL. And so I think that's we're still working through like what the prompt first developer experience should be. And it's far, it's just not at the level of maturity that other developer systems are.
Yeah, choose your own journey wisely.
Yeah.
Is maybe one way to think about it. Cool. So let me ask you about a couple of some, kind of heated debates or sort of topics of discussion in the industry. The first question for me is, should we prepare for a future where we're all going to have our own chatbots, our own agents walking us, following us around? What does sort of the personal future look like in your opinion?
Yeah. Well, I think first of all, it's just kind of wild that chatbots have become so big. I mean, I started working on one of our internal chatbots called Lambda back in 2019, and it was just an awesome set. Like I used this early build of it, which basically required like running a little supercomputer just to run, but I was just blown away. And what was wild is that it wasn't implemented as a chatbot. Like you think you're having a conversation, but really you're just putting your input to a model, and if you ask a question, and it's predicting the next probable tokens, it'll put out an answer. So you're having a conversation, but it's not built like a traditional chatbot was like the user provides some input, we process that input, and then we provide output. And there's this like inherent conversation. What's so wild is like we still call these things chatbots, but they're not actually chatbots. Like if you say write some code, it writes code. Well, that's not really a chat. That's just it's spitting out code. And so it's really like they're really kind of chat interfaces to a LLM. And I think that user paradigm, like anything with a text box, is probably going to have an LLM on the back of it at some point in time. And so I think that, we may not always think of it like a chatbot in the same way, like we've been putting LLM technology in search for ages. I mean, Sundar would talked about BERT on earnings call 3 or 4 times. When we developed the transformer, we built this model called BERT. The T in BERT is for transformer, and we've been putting that in search for years. And users just notice that search get better, like our improvements in document understanding or query understanding, they just make search work better. And most users don't even know. They don't even know that they're just, because we took a text box and we started putting language model technology behind it, and the results got better. And we didn't say, hey, you're talking to a chatbot. And so like search just got better. And so I think more and more, you're going to see more and more of that, where, Google is just kind of living in the future, but like a lot of interfaces that have text boxes, you're going to see, LLMs plus databases getting integrated. And then, just every question answering system you see is just going to have better natural language understanding, because people are going to be putting language model tech in it. So I think there's going to be one level where just like all of these products get better, but then there are for sure new classes of projects. I mean, there's definitely new things that are more like agents. If you look at how people, for example, like what you can do with Bard that you can't do with traditional products. It's multimodal. It can use tools. We're going from kind of chatbots where it's like language in, language out. Well, now it's like language in, code out, and like taking actions, and it's like speech in, speech out, and image understanding and text out. So like pretty much we're going from text to text, so like every modality to every modality. And as the models get more and more powerful, they're useful directly, in not just kind of like there's lots of opportunities to embed the technology in all the kind of in products and experiences we have today, but there's also going to be new classes of products as well. And I think likely we're just going to be on a phase of exploration for a while. There's kind of a wave of everyone making products better incrementally by deploying the technology. There's going to be huge, there's a ton of startups and companies launching new products where they're exploring like what new products could be developed based on this new underlying tech. And I think that's going to be 1,000 flowers blooming, but you can already tell that I think some concept of a personal agent is going to work. And I think the question is just how ubiquitous it is. Like, I think Her is a long way off in terms of like actually getting to a system like that. And it may also not show up in a way, in the same way, like movies are often and books are great, like sci-fi is a good kind of way. The smartphone, I think, was, in books decades before it came out. But sometimes, those mental models get things wrong, right? Like we originally thought, oh, those be like a robot to wash your dishes. And it's like, no, actually they're just dishwashers. Or like a robot will like drive your car. No, actually just the car drives itself. Like you don't put a robot in a car, the car just drives itself. So I think there are areas too where sometimes we get it wrong. Where like if you think of how you use your phone, which is like the real, like we called the PC the personal computer, but your phone is the actual personal computer. And so I think there are going to be ways where like phones just start doing more and more, and they become more like these personal agents too. So I don't know that I think they're going to be new and interesting product form factors, but also like the ones we use today are going to, are pretty durable and are going to get better in the same way like cars have existed 50 years, but self-driving cars are quite new.
Yeah, love that. I love the analogies. I think we have some awesome questions from the audience that we'll get to in 1 second. I have one more debate question for you, which is open versus closed models. Lots of opinions on that topic.
Yes. I mean, like one of the things I love working developers, there's always these like cage matches of approaches. So I spent a long time in the database world, specifically working on open source database technology. And I remember there's just, big first debates of like, oh, you've got proprietary databases, from Microsoft, IBM, Oracle, et cetera. And you've got all of these open, MySQL, MariaDB, Postgres, et cetera, all these open databases, which is going to win. And like, it turns out they all won. Like the database market is just massive. The same thing with like operating systems. I used to work on operating systems, and people say, "Oh my gosh, open source and Linux is going to win," or like Windows and Mac OS. And like if you look at across the board, like there's never been more Windows PC installs. iOS is quite popular and growing. Android has like is the number one operating system. It's open source and number one operating system in terms of like installed units from mobile. Linux is doing incredibly well on the cloud, and then in enterprise, Chrome OS is doing incredibly well with like students. It's Linux, built on open source. It's Linux. So it's funny, like even for something like a category even older than databases, like operating systems, both open and closed approaches are quite successful because these markets are just massive. So if you look at databases and operating systems, so there's just room for it's not a zero-sum game. Like there are just rooms for multiple approaches, and I think the same is going to be true for models. I think we are really early innings in terms of models, and so I'm bullish about. I think open models are compelling to developers. I think and they have been for a while. Like I said, BERT, 4 million downloads just last month, right? And that's an old model. That's not even a new model. So open models have been compelling for a long time. They're going to continue to be compelling, but also for these more capable models, I don't know that that's open is going to be the approach for them. Like there's huge amounts of infrastructure. Like when you consume a LLM API at this point, it's not just a thin wrapper around the LLM. Like there's a huge amount of infrastructure and a huge amount of advantage you get to building those at scale that you want. If you take an open model and run it on a cloud GPU, that's not nearly as cost efficient as taking, using an API, which is backed by like much more scaled infrastructure. And so I think if like you're experimenting on your laptop or like a new mobile app or on the cloud, open models are great for that. And you want to like create your own fine-tuned variant, et cetera. Perfect. If you're running something at large scale, it's like unless you yourself have the ability to scale out your own infrastructure, they're not going to, the cost performance is pretty tough. So I think like with all of these systems, there's going to be different market segments, different technologies that are kind of better or worse for those segments. But of course, like the debate will rage on. Yeah. So
we still need the cage match.
As they do, exactly. We need to have fodder for Reddit, right?
Exactly. Awesome. Okay, so we have some great questions from our audience that I'll read to you if that's okay. Question from Stevie in the live chat. So Stevie's asking, how are DeepMind's underlying technologies, such as reinforcement learning and neural networks, being either evolved or repurposed to tackle domain-specific problems in fields like genomics, energy efficiency, or real-time natural language processing?
Yeah, so a great question. Thanks, Stevie. So RL has been wildly, when DeepMind, one of the first breakthroughs DeepMind had was using RL to learn on the pixels of like 1980s Atari video games, and then learning like just from doing RL on the pixels, like learning how to solve them. Now, obviously, like the goal wasn't to be like Gen Xers at games that don't kind of play anymore. It was really, games were just like the right harness for RL research, and out of that came a whole series of like innovations. You may have seen like the AlphaGo movie. And the whole series, AlphaStar, a whole kind of series of investments that actually eventually led us to AlphaFold. And so now you see, that which has been adopted massively by scientists. Like people are using it for, a huge amount of applications on kind of predicting proteins, like drug development, as well as we've had recent results where, the technology have gone beyond proteins. So there's a huge, I think there's this, if you can see like pioneering advances in RL already are having pretty significant impacts in the scientific community. We're also using RL quite heavily in product. Like you may have heard of something called RLHF. Like you'll often hear people throw around the acronym, which is reinforcement learning on human feedback. And so one of the ways you can improve your LM in the context of an application is doing reinforcement learning and having what's called a reward model deployed as part of the application, where you're using reinforcement learning either while you train the model or after you've deployed the model to further improve the quality of an LLM. And that's one of the techniques that, on the Google Brain side, we had pioneered with Lambda, and it's now very central to Bard. And so RL has been just amazing in terms of it's really kind kind of groundbreaking research that took years to come to kind of fruition in product context. But RLHF has been a huge deal for the kind of chatbot ecosystem, and AlphaFold has had a massive impact in the scientific communities. And so it's kind of a good example where some of these foundational technologies are getting deployed now in kind of either domain specific or product context.
Makes sense. Awesome. Love it. So then I think we have a last question here. We have time for maybe one more. It's actually two-part. The first part is Annie Duke earlier today talked about knowing when to quit at the right time. So when do you or DeepMind, Google know when's the right time to quit or to stop working with the right model? And then the second question is, what do you anticipate to be sort of the next sort of big moment in generative AI, either sort of an architecture, tool, or type of model? Yeah.
So when to quit, that's a good, I've listened, I've not read her book, but I've listened to her podcast on the book, and it sounds, it's a fascinating area. I mean, one of the things we think a lot about, so we're a research organization. And so often, think from an engineering perspective, there's a desire, like if you have a breakthrough, like you make an advance in terms of some form of RL, and then you apply that to a product application and you get a win, there's a default tendency to just keep pressing that button and like racking up that, like, oh, we made it better, like let's optimize it even more. And it's like, clearly, there's this real trade-off between like explore and exploit. And so when you've made a ton of investment in exploration, and then you start to exploit that investigation, to build something that's to improve your products, it's always it's not so much like, it's the when to quit for us is like, how do you balance explore and exploit? Like you on the one hand, you want to exploit the wins of the technology. On the other hand, like our core mission is really to explore and like develop breakthroughs. So we have, we try to get out of the business of the deployment. And so we'll often be involved in like initial deployments. So for example, like we're very core to the development of Bard, like myself and much of our team. Because so much of it is research as a product. But as products tend to grow and scale, more and more of that just becomes product development. And then from a research perspective, we'll want to go back to like, what's the next advance that will drive some major advance in Bard? And so the challenge with these things, like quitting anything, is that it's not black and white. Like it's always, everything is gray. And so, and everything involves risk, right? And so you really have to, I think the biggest thing, you're going to get it wrong. Like no one gets these decisions right all the time. But I think if you have a system by which you kind of can talk about your explore exploit balance, and like how you're too far off on one end of the spectrum, then at least, and you have a kind of a practice of regularly having that conversation, then you can at least stay on top. You may not get it right or wrong all the time, but at least you have like a philosophy for how you manage it.
Love that.
Yeah.
Explore, exploit. Amazing. Sounds great. Well, thank you so much, Eli. I feel like I told you this, I have like 100 more questions for you. I could spend probably a lot more time asking you so many of these questions, because it's all fascinating. So really like such an exciting time. And thank you for taking the time to share some of your sort of insights on this. I'm sure we'll continue to battle some of these things later and kind of figure out, what's sort of best for the industry. But thank you so much. Next up, we have Lior, our CTO and co-founder of Monte Carlo, sharing sort of our vision for the future of reliable data. But until then, thank you so much again, Eli. It was so fun, as always. Really appreciate it.
Yeah, thanks so much, Bar. And thanks so much for the great questions, everyone. See ya.
Hi, everybody. I hope you enjoyed the conversation between Bar and Eli earlier. Some great points there around AI, and I think we saw some of the common threads from other conversations we've had today around the increased adoption of data and AI. Require getting the foundations right, whether it's privacy or security or scalability, and of course reliability. And that last part, reliability, is what we'll mostly talk about in this session. We're excited to share some of our learnings from the past year around reliability and what we're planning for the next year. So without further ado, we'll jump right in. My name is Lior. I'm co-founder of Monte Carlo, and I'm joined here by Bryce, who's a product manager with us. We'll walk you through some of what we've seen this year. I haven't had the opportunity to win $1 million in a poker hand or to be portrayed by Brad Pitt. But I have had the pleasure of helping over 300 companies by now make their data more reliable and adopt data observability. And so everything that we're sharing today is derived from that experience and from those learnings. And first and foremost, I just want to thank all of our customers and our partners that have basically taught us everything we know about the topic. There are 3 trends that I'd like to share today. The first is going beyond anomalies. Oftentimes data observability is thought of in the context of anomaly detection and its application to finding data issues. Today I'll explain why data observability is so much more than that, and why there's a much broader set of capabilities that's required in order to deliver data reliability. The second trend I'll talk about, which ties to the kind of broader macroeconomic wins this year, is about efficiency. So this year, efficiency was not optional, and a lot of data teams had to deal with that. And that meant a lot of things for data teams and for the observability space as well. So we'll talk about some of the learnings there. And finally, last but not least, we'll talk about probably the biggest trend of the year, which is generative AI, and what does it take to make generative AI happen in the enterprise. Our marketing team has asked me to make sure you do not forget that we're going to talk about generative AI. So here I am reminding you, there will be a conversation about generative AI. Stay tuned for the latter part of this talk. Starting with the first trend. We at Monte Carlo have been talking for a long time now about data downtime. Data downtime is basically times when data is broken, erroneous, missing, duplicated, or kind of otherwise unfit for its purpose. This is probably the second year that we're running a survey, and we do it across hundreds of data professionals, not our customers necessarily. And try to measure how it's evolving. And what we've seen this year, kind of as we expected, that overall data downtime is increasing, right? It almost doubled in our respondents' answers between 2022 and 2023. And even more than that, data downtime had much more revenue impact, whether it's through diminished growth or increased cost than ever before. The reason for that is pretty simple. Companies are doing more with data and using it for more and more mission critical use cases. And therefore, when data is down, it's much more painful from a company performance perspective. And because we're building much more and using many more sources and increasing the size of our data teams, things are getting more and more complex. And therefore, data downtime is more likely, not less likely, to happen. Now, how are we as an industry dealing with that? We've been talking a lot about data observability in the last few years. We believe it's not the only necessary part of the toolkit, but it is a very important one. And data observability, in a sense, started from anomaly detection. And let me explain. For a lot of data teams historically, doing data reliability meant adding tests to data pipelines, right? Whether it's DBT tests or Great Expectations or your own internal framework that you use for testing. And data teams quickly figured out that was not scalable, right? As you have more pipelines and more tables and more tests, things start to get out of hand. You start getting a lot of noise, and you start to struggle with keeping up with all the things that can break. Now, as a data observability industry, it started out from saying, well, we could use machine learning to make some of this easier, and give teams ways to basically run a lot of tests with the click of a button, right? Basically scale and automate this entire thing and apply anomaly detection to it, so that people don't have to necessarily predefine every threshold and every piece of logic, but rather let a learning algorithm figure it out. Now, fast forward 4 years, and the world looks a little bit like this little cute puppy in the picture in front of you. We have anomalies. We can spot nulls where they're not supposed to, or metrics that are unusually higher or lower than what we expect. And we've done a great job with anomaly detection. But that's not enough, because what you get when you basically focus on finding anomalies is a lot of fire drills surrounding you at all times. And when given no context about those issues, when all you get is an alert saying, hey, there's nulls here, or something like that, what most humans will struggle to understand the context around it, right? They will struggle to understand, well, the fact that we have nulls here, why does it matter? What does it impact? And if it does matter, why is this happening? What's driving? What caused it? And historically, the workflow to do something like that involved going through a lot of different systems that are part of the data stack, whether it's the orchestration tool in your data warehouse, and your ingestion tools, and your testing tools. You'd have to go between all of these different tools, run a lot of queries, parse through a lot of code on GitHub to understand what happened. And that's a very tedious task, which means that if all you do is throw anomalies at people, they will gradually get fatigued and stop responding to them. And so at Monte Carlo, we've been investing a lot in giving people, not just anomalies, but also the context that they need in order to triage them, and then, when appropriate, to solve data problems. So let me explain a little bit about where we invest in that. The critical insight to understand here is that when data issues happen, there's typically 3 reasons why they may have happened. The first reason is there may have been a change in the data that's ingested by the system, a change that was unexpected and that the system could not handle. A classic example of that is, if a software developer changes the application and drops a field that was particularly important, or populates it with nulls, or changes the units, things like that, it is very likely that a data pipeline that relies on that field will break and will have unexpected results. The second reason why data issues happen is what we call system, right? If the orchestration tool you're using failed to run a job, or even is not performing well and is lagging, or performed the job but failed to write the data back into your data warehouse or data lake, you're going to have a data problem, right? And so you do need to understand how the system works in order to analyze a data problem. The third piece is code, right? Every data system is a series of aggregations and filters and joins and other types of transformations on data that eventually produce a data product, right? Maybe a metric that you really care about, or a training set for a machine learning model, or risk scores that you're using in your pricing application. That code is written and changed, modified by humans, and they sometimes make mistakes, and they sometimes make changes that have unintended consequences, and that can easily create a data issue downstream. Monte Carlo today can give you a full picture of how all these three components interact in order to create the data. So when you're looking at a data issue, say, a field that's missing values, Monte Carlo will help you understand first at the data level, when did this issue start? What did that data look like in the past? Are there certain segments or parts of the data that are highly correlated with the issue? That can also help understand where it's coming from. But we go much deeper than that. We will also help you understand what happened with the data as it's been processed all the way from the source and to the data issue that you're seeing, both at the code and transformations that work through that data, and at the system that produced that data. And so to give you a practical example, Bryce released this year our airflow observability solution. So Bryce, maybe tell us a little bit, how does airflow observability help our customers correlate data system code?
Yeah, yes, it's really about the context, right? As you mentioned, it's connecting these things. So data has been an area we've been focused on for so long, and looking at the outcomes that's happening in these transformational systems, right? But airflow observability actually connects those data issues to the code that generated that data, as well as the operational system and issues that may have ran with that code, right? There's companies that are focused on solving some of those like infrastructure side issues around airflow or transformation of data, but that's not really enough in a silo either, right? We have to think about how these things connect. And we heard from many of our customers that connecting the data back to the system itself with, for airflow specifically, right, was a real challenge to say what DAG actually populated this table. And with Monte Carlo now, we're actually automatically pulling those things together. We're giving you right in there as you're looking at an incident. Where did that issue come from? Did it come from an airflow DAG that failed or ran too long or was delayed? And giving you that lineage right upstream.
Right, and you can pinpoint all the way to the code that ran that particular task and how it changed over time, right? And that's a critical part, and a critical part of piece of the context that our users need when they're addressing data issues. And going back to the fire drills, that really shortens the time it takes to get all the context you need and to resolve an issue, and therefore reduce data downtime, right? Because what we've learned is that data downtime, a lot of people, first think about how long it takes to find an issue, right? Because historically you would learn it from your end users. But even if you can detect it very quickly, you still need to solve the problem and find the root cause. And that is a non-negligible part of data downtime, as much as 80% sometimes, right? Totally. So moving on, and I want to talk about another aspect that's often overlooked in data observability. And it's the idea that data reliability is a team sport, all right? When you start with a small team, maybe there's one person who's kind of focused on reliability and quality and who's driving it. But as you scale your team, and for a lot of our customers, any data product is the result of at least 3 or 4 teams, right? Whether it's the teams that are generating the data in the first place at the application level, or from the marketing stack or whatnot, through probably a platform team that helps ingest that data, one or two data engineering teams that transform it and clean it up and prepare it for analysis, and then oftentimes an analysis or data science team that produces the final dashboard or the final model that's used by the business. And the reality is that you can't ask one person or even a group of people to make sure this whole system that's produced by multiple teams works well. It just doesn't work. And we've seen in the past in other domains, right? I even remember the times where engineering was separate from ops, and we tried to develop code and to run it completely separately, and that didn't work. We had to create DevOps, right? We had to bring the reliability and security aspects into the development workflow. And we're seeing the same happen in data. You can't punt data reliability to someone else. The people that build data, that build a specific data set or a specific data product, need to also own its reliability. And so Monte Carlo has built a lot of tools to help democratize data reliability and give every team the tools that it needs in order to gain visibility into its data downtime, to monitor and alert for it, and then respond to it, as we've just talked about. The other element of it is, if you're a leader or a platform team that's trying to get an organization to deliver data reliability, that can get tricky. Getting 5 and sometimes 10 or 15 teams to do something can be less than trivial. And so at Monte Carlo, we invested a lot in helping leaders and platform teams actually coordinate and orchestrate a data reliability effort across multiple teams. And that requires a bunch of capabilities. Let me walk you through some of them that we've built this year. First, it requires measurement. In order to manage data downtime, you actually need to measure it and understand how it's changing, and understand whether it's getting better or worse, and then how to improve it, right? And so we've built a set of comprehensive dashboards that really help measure data downtime, measure data SLAs, all the way down to very, very granular definitions of quality. And that information, that visibility, actually helps teams understand where they are, how they're faring in terms of reliability, and how to improve it. And more importantly, it allows leaders and platform teams to hold teams accountable to it, right? Because if you want the end product to be reliable, you have to make sure that all of these teams create reliable data. And so that made a huge difference for some of our larger customers that tried to implement data reliability at scale. The other thing we shipped is a built-in capability to measure the health of data products. And think about it. A lot of times in data reliability, we think about tables, right? How do we monitor this table or that table? But the reality is that we need to transcend that, right? We need to think about the product that we are actually shipping to our end users, which again could be a dashboard or a model or an application. And that product depends on a lot of upstream pipelines and transformations that happened across multiple teams. With the data product dashboard that we introduced this summer, teams can actually understand data products and measure the reliability of a data product and not just a table, which encompasses all of its upstream dependencies automatically mapped by Monte Carlo's lineage capabilities. The third critical piece is we've made domains, which is a concept from data mesh. And whether you adopted data mesh or not, we see most teams adopt some of these ideas, whether they call it that or not. And so data domain speaks to the idea of essentially dividing the data ecosystem between teams and responsibilities, right? It could be based on business function or data source or use case, or however it makes sense for your business. But the idea is to assign ownership and make sure that every data domain can function independently of the others and manage its own reliability. Domains is a concept that's very native to Monte Carlo. You can define domains, you can assign people to domains, you can make sure domains are owned, and you can analyze everything at the domain level. And that not only allows people to focus on the things that are most relevant to them and reduce fatigue, but also puts the right security and privacy guardrails that some of our larger enterprises need as they adopt a data reliability or any solution for that matter. So that's been very exciting for us this year. Switching gears, you haven't been under a rock this year. The economy has been struggling. Interest rates are higher than what they've been in the previous decades, which means that companies are looking with more scrutiny at their expenses, right? And data teams are no different, right? They're part of the companies that they operate in, and they are asked to look at cost as well. Now, what does that mean? That means that all of those jobs and queries that we've written over the last few years, and maybe we turned a blind eye to how efficiently those queries and those jobs run. Maybe it wasn't as important. But now we have to go back and look and understand, hey, how do I make this entire thing deliver the same value or even more value with less cost, right? And there's been a lot of media attention around the Snowflake and Databricks bills and how they can be slashed. And so we've seen a lot of our customers dealing with that. And it goes beyond cost, right? Inefficient jobs also hamper a reliability, right? They make the user experience bad when you're trying to load a dashboard. They make jobs delayed or more likely to be delayed, and therefore data to not be fresh. And they make testing and debugging much harder, and backfills more costly. And so they're directly tied to the ability to deliver data reliably. And so this year we were very excited to launch performance observability. Performance observability is a tool that basically gives you a lot of deep analytics about runtime and cost of all the jobs and queries that are running in your system, right? And so we can not only understand individual queries and how they ran, but actually understand how a job fared over time, how a specific query trended, and even understand what are the queries that are for jobs that are driving the most load on warehouses and the most cost. We've had customers use it to great effect to optimize their existing jobs. We've helped our customers also put proactive alerting in place so that it's not just a one-time effort to optimize the system, but rather a way to manage performance over time and get alerted when things go out of hand in the future. And we've made this whole system DAG aware. And so if you're running dbt or Airflow, DAGs are a first-class citizen in our performance observability solution. They help you understand not just how individual queries are performing, but actually how they perform as a whole as DAG. What are the bottlenecks? What are the DAGs that are performing or well, and what are the DAGs that are not? And so, Bryce, maybe you can share some of the reactions we've heard around performance observability this year.
Yeah, absolutely. I mean, this is a whole new workflow around observability for Monte Carlo, and our customers have been really excited to share some of the workflows that they've put into place. Where previously, one customer shared that they were writing scripts to run this in monitors like in DVT, on a manual occasional basis, right? And he shared the best part is that I can put this directly in the hands of the data analysts that are writing these models, right? And so having that UI that gives all of these kind of visuals and having the monitors in place is really helping there. And another big great customer also shared that they were trying to track performance themselves before using Monte Carlo, again with kind of scripts, and I quote, having something simple and in one place is a complete game changer. So it's exciting to hear that people are really digging into this.
Right. And we've made the effort of adding very granular metrics at the warehouse level, whether it's caching or snowflake or spillage, or slots on BigQuery, to make it really easy to map performance issues to configuration in to your particular setup. Now, moving on. Let's talk about Gen AI, right? We promised to not keep you too long without another conversation about generative AI, and so again, I'm probably not saying anything new, and when I say that generative AI will revolutionize the business world and will do a lot to make humans more productive. Generative AI models can do a lot of things, but first and foremost, they enable teams to really deal with unstructured data in a way that's never been seen before, right? It's that access to huge bodies of text and sometimes images and videos that really is going to unlock a lot of power. And of course, the conversational aspect of it that allows you to interact with that data and ask questions of it. That's pretty amazing. And I think what we've seen this year is that, generative AI is absolutely going to rely on proprietary enterprise data. And what I mean by that is you can go to ChatGPT today and get a lot of facts about the world, right? And it's all from the public domain, from the internet, right? Which is the data set on which it was trained. But if you think about many of the business problems that we have and business applications that we want to build, they require deep knowledge of the specific company, right? Its products, its customers, its strategy, its transactions and facts. It is very difficult to answer a business question without knowing anything about the company. And so models are going to have knowledge about the specific enterprise within which they operate. Now, there's two ways that have been devised so far to do that. One is RAG, or retrieval augmented generation, which is the idea of, let's put our data in a database, oftentimes a vector database, but it could also be other types of databases. And let's use the prompts and the questions that we get from the user to basically retrieve information from that database and feed it to a generative model in order to synthesize it, summarize it, and answer the specific question that the user had. So these databases basically add context and long-term memory, if you will, to models. More importantly, they address a specific issue that exists in generative models, which is hallucinations, right? Retrieving information from a database makes sure that that data is curated, trusted, reliable, and accurate, which is very compelling in the generative AI world. The other way by which we teach models about proprietary enterprise data is what we call fine-tuning, which is the idea of, let's create a labeled data set that we basically feed into the model as part of a learning and optimization process, which basically embeds that knowledge into the model and makes it aware of information that wasn't necessarily there when it was trained on public domain data. Either way, you will notice, whether it's RAG or fine-tuning, we're talking about a data pipeline. We're talking about something that takes a bunch of data sources, typically unstructured, transforms, cleans them, combines them in various ways, and makes them available to a model, either as a training set or as a live database that's used during runtime for retrieval. And we believe trust and reliability is extremely important there, because if you're going to have a model serve bad data, you're going to get bad results. And it just doesn't matter how smart and capable the model is, right? And so it's back to those foundations of reliable data and how do we make these pipelines reliable? And so I'm super excited to make a couple of announcements today around how Monte Carlo is going to help companies build better Gen AI pipelines. And so Bryce, maybe tell us about our first announcement of the day. We're announcing support for Kafka and specifically Confluent Cloud. Can you tell us more?
Absolutely. Yeah. Well, while streaming data doesn't necessarily need to always be part of Gen AI pipelines, and we don't think batch processing is going anywhere anytime soon. We're hearing from customers that this is coming more and more into focus, right? And there's other services that may be kind of focused on like the system side of it, right? Going back to your kind of system code side of things, right? But we want to be able to basically look at the data side of it too, right? That's going to be critically important as we think about streaming data coming in and having these coupled in with the context of where these data sets are heading in, and the consumers that are sending in there with these Kafka topics to land within your data storage layers. We want to make sure we have that entire context within the pipeline. So we'll start with Kafka and Confluent, and we'll see where that takes us.
Amazing. And the final announcement for today, we're also excited to launch a capability around vector databases. Tell us about that.
Yeah, if you heard Victor speak earlier today, Credit Karma told us a little bit about trusted data is going to be a critical part of these generative AI experiences, and we're extending that trusted data experience you get with Monte Carlo and data observability out to vector databases as well. So we'll look at things like metadata within these vectors, as well as freshness as data lands there, and making sure that it's working and up to date.
Amazing. Thank you, Bryce. Thank you, everybody, for joining us on this conversation. We hope you learned something interesting today, and feel free to reach out to Bryce or me on LinkedIn if you want to learn more. Thanks for joining us.
Thank you.
It's my first day as a data engineer. I've jumped into some Python, some AWS, and I've been able to meet everyone through so many meetings, and everyone's so nice and so helpful, except the staff data engineer. I haven't been able to reach him, but maybe I should schedule a meeting with him. Who knows? I'm still excited. 2 months into my data engineer job, done some pretty cool stuff. Got AWS certified, which was a lot of fun. I still don't have access to production, so that kind of sucks. But I've been jumping in with some data quality problems, doing a little bit of cleaning here and there, working with the rest of the team. It's been great. We have a culture of like a lot of meetings, so it does kind of slow down my work, but I'm getting used to it. Hopefully this doesn't impact, end of the half, and we'll clean things up before the end of the year. 1 year as a data engineer, and I've given up. Every time they ask me to build a dashboard, they end up building a model in Excel. Apparently some intern figured out VBA and it works, is good enough. Data quality problems are still here. I can't sleep over some of them. And there's just so many meetings, I can't get anything done. I feel like I'm working so much. And I've worked so much that I haven't been able to get a haircut for the past year. Like, this is bad.